So this was a surprising miss for many students in CP Math 1. It says graph the following equations on one set of axes. Maybe that's it, you didn't like this. Maybe this isn't the plural of axis. Axes? Anyways, on the first one, my y-intercept occurs at -6. So maybe you don't know this, but look, if I've got a table of values, here's x's and here's y's. If I pick an x, say x is 0, and I plug this value into the equation, right, this becomes 0 minus 6, which gives me a -6. I can do the same thing with another value. I can say, hey, what if x is 1? I'll take this 1 and plug it in here. Hey, this then becomes 1 minus 6, which is -5. If I want, I could jump all the way. I'll say, let's put in 5. So if I jump in and put 5, this then becomes 5 minus 6, which is -1. So just based on those 3 points, right? 0 is going to -6. That's right here. 1, 2, 3, 4, 5. This is -6. So this is the first point on that graph. And then it says that 1 is going to -5. And if you look at it, 1 goes to -5. That's the next point over right here. 1 is going to -5. And then I jump all the way up to 5. I can go 1, 2, 3, 4, 5 is going to -1. So I quickly see this is the first line, right? This is the line y equals x minus 6. Now, that's just me plugging in some values and seeing the table, and as it as it materializes, I'm just plotting those points. I can also observe the slope in the y-intercept, right? The y-intercept occurs when x is 0, so the y-intercept is at -6. And then this, I think, caused confusion. There's no coefficient here, right? There's no coefficient in front of the x, so that has to be the number 1. And if you like, you can write it as 1 over 1. So what's nice is now you can see that slope pattern of up 1 over 1. So if I'm starting there at -6, notice what I'm doing with this. I'm going up 1 over 1, up 1 over 1, up 1 over 1. So that's clearly this first equation. Now the next one that's there, I need to get y alone if I want to try and graph it using the y-intercept technique, or even if I wanted to make a table of values, it would be better to have y alone. Well, in order to get y alone, I can divide both sides, every single term on both sides, by 3. So I can do this, right? Or I can divide, instead of dividing them both by 3, it's like I can divide both of them by 3. Another way to think of this, and this might be more convincing, is literally I'm multiplying both sides by 1/3, right? So if you look at this, I've got 3y equals x minus 15. So I can definitely multiply both sides by the same value. And you can see when I multiply the left-hand side by 1/3, 1/3 times 3 gives me just plain old y. And then when I have to distribute this 1/3 into each of these terms, right? Notice what I get. I get 1/3 of x, and then -15 times 1/3 would be -5. So I can see my y-intercept b, right, is at -5, and I can see my slope pattern. It's up 1 over 3 units. And that's the second line that I have here, where I'm starting up above. I'm starting at a y-intercept at -5, and then I'm going up 1 unit, and then over 1, 2, 3. Up 1 over 1, 2, 3. Up 1 over 1, 2, and 3. You see, over here, up 1 over 1, 2, 3. So this is the second line, and the line, you can write the equation is this modified form, right? Y equals 1/3 x minus 5, but it's the same line as 3y equals x minus 15. It's two different ways of writing the same line. This is probably more useful for graphing. And that's it for question number 9.